In this lecture, we'll talk about the various ways to scale your AWS resources properly to meet the demand. Scaling can be done in each layer of your architecture, in the front tier, middle tier, and the data storage tier. There are also two types of architectural models that you can choose from to satisfy the scaling requirements of your application or your system. It can be either a push model or a pull model. We'll also cover the different features of each services that you can leverage as well. Let's start. The very first thing that you have to consider is the type of operation your application process. Is it read intensive or is it write intensive? For example, news websites are read intensive because the user just reads data and does not write anything or doesn't send any data. Another example will be reporting applications, where it just queries the database and processes the data. Applications such as voting, monitoring, or transaction management systems are write intensive. You always write data in this type of system most of the time. By knowing if your system is read intensive or write intensive, or even both, you can appropriately create a scalability solution and architecture for your system. In this case, there are two basic types of network architecture. We have the push model or the pull model. Push model is where the workload is directly pushed to the servers which process the data. Pull model, on the other hand, is where the workload is pulled from a queue by a fleet of servers or service workers. You can use autoscaling and SQS for these types of architectures. To scale your front-end layer, which is comprised by your public-facing web servers, you can use autoscaling for your EC2 instances. When the workload or demand spikes up, the autoscaling group will automatically scale up as well to meet the demand. You can also use the routing policy of Route 53 to provide latency and weighted routing to improve performance. CloudFront and Elasticache also offer scalability for read-intensive applications by caching the frequently queried data. In this way, it reduces the unnecessary step of querying the origin server again and again and again for the same exact data that was fetched a while ago. To scale your middle tier, you can use Amazon SQS to provide a threshold and a queue system for your workload. The servers will fetch the messages from the SQS queue, which automatically scale up if the demand goes up, and scale down if the demand goes down as well. In case that there's a surge of demand, you can add some spot EC2 instances to process the backlog. This can be configured using Autoscaling and CloudWatch. You can then terminate these spot instances once the demand goes to stable levels again. And lastly, to scale your data storage layer, you can create a read replica in RDS to improve the read throughput of your database. If you're using DynamoDB or S3 as a storage service, scalability is already handled by AWS.